Welcome everyone, and thank you for joining a new Growth Acceleration Partners webinar. First of all, I'd like to give you a quick summary of our company in case you're not familiar with us. GAP, as we usually call it, is a strategic technology solutions company that provides an exceptional experience in digital transformation, software, and data solutions through our world-class consulting and engineering teams. This webinar is part of our DevQA Fusion Fest, and today we have Jennifer Castro and Juan Jose Barboza, who will be presenting the topic Blending AI with Automation, a game-changing approach to chatbot testing. So both Jennifer and Juan Jose work in GAP's QA department. Jennifer is a QA automation engineer that specializes in creating tailored test frameworks and developing solutions from the ground up. She has extensive experience with automation tools like Selenium, Cypress, PyTest, and JMeter, and is proficient in programming languages such as Java, JavaScript, C#, Python, etc. Jennifer holds certification as an ISTQB certified tester at the foundational level and as a test automation engineer, as well as the Microsoft Certified Azure Fundamentals certification. On the other hand, Juan Jose has been working in QA automation for over 8 years with a strong focus on both manual and automated testing. He specializes in testing frameworks like Cypress, PyTest, and K6, and has a deep expertise in Python and JavaScript. He holds also several certifications, including ISTQB Certified Tester Foundation Level, ISTQB Advanced Level, Test Manager, AWS Certified Cloud Practitioner, and Microsoft Certified Azure Fundamentals. He is driven by a passion for technology and is continuously exploring new tools and frameworks to enhance testing efficiently and effectively. Jennifer and Juan Jose, thank you to both of you for being here, and the stage is all yours.
Thank you. Okay, first of all, hello everybody, and thank you for joining us in this presentation. Let's first talk about the context of this project, basically why we are having this presentation today, why we have done this work. And for that, let me tell you that at GAP, as part of our AI strategy, we have been working on developing an internal chatbot that leverages AI to understand and reply to employee questions. The idea with this chatbot is that it is going to provide information regarding different topics of the company, such as human resources, IT, promotion guidelines, certifications, and so on. And since this is an active project, an active development project at GAP, we need to test it properly. We need to make sure that the chatbot is giving correct answers, accurate answers, and reliable answers. So we started thinking how we could approach this testing. Since we are talking about an AI application, of course, it presents new challenges for us. But before talking about this planning phase, let's talk about a couple of concepts that they are very important to see the challenges that we are facing with this kind of applications. Let's talk about deterministic and non-deterministic applications. A deterministic application is when having the same input, the application is going to generate the same output every time. So in this case, if we have A as an input, the application is going to generate B as an output. As I said, always, every time. That's how many of the traditional applications work. And if we speak about testing for those kind of applications, we can have a validation like output should be equals to B, for example. That's how we write most of our automated tests, right? But if we talk about non-deterministic applications, in this case, even if we have the same input, the application is going to generate different outputs every time. In this example that we have in the slide, if we have A as an input, the first time the application is going to generate B1 as an output. The second time the application is going to generate B2 as an output, and so on. As I said, even if we use the same input. In our case, the chatbot is a non-deterministic application because even if we have the same input, if we have the same question, the chatbot is going to generate a different answer every time, probably with the same meaning, very close, the answers, very similar, but still slightly different. And that's why we can say that the chatbot is a non-deterministic application. Okay, so in this analysis phase and in this planning phase for testing, we ask ourselves this question. Are conventional automation frameworks sufficient for testing AI-powered apps? And after some analysis, we concluded that definitely not. If we follow a traditional testing or automation approach, it is not going to be enough to properly test these kind of applications. And let me mention some key reasons behind this answer that support this answer. The first one is that in this, let's talk about the chatbot. For example, we are going to have a high input variability. And let's think about this scenario. We want to know who is the leader of the human resources department. That's the information that we want to know. We can ask this question to the chatbot in very different ways, depending, for example, on the level of English that we have, depending on the communication style. For example, we can use a formal communication style or we can use an informal communication style. And based on that, the question, the wording of the question is going to be very different. If we talk about the output, in this case, the chatbot answers, as I mentioned before, since it is a non-deterministic application, this output is going to change every time. So in this case, we cannot have this static validation that I mentioned before. Something like output should be equals to, it is not going to work in this case. Also, with these AI applications, we need to validate some, let's say, new attributes in the responses. In this case, in the chatbot, we need to make sure that the chatbot answers are following a professional and a polite tone in the answers. Okay, before going deeper on how on our testing strategy, let's check some AI concepts because they are going to help us to understand how AI is being applied in our testing framework. The first one is artificial intelligence. That's like the big concept that encapsulates a lot of things. Basically, it is the simulation of human intelligence in machine. And this enables machines to perform actions that require human intelligence. Natural language processing, it is a field of AI, and it enables machines not only to understand human language, but to generate human language. And for example, being able to have a conversation between a person and a machine. We have semantic similarity. This is a very important concept for us because it helps us to measure how similar two pieces of text are in meaning. And let's check the example to clarify this concept. In this case, we have three different questions. Let's check first the two questions at the top. How are you and how old are you? If we analyze these questions, we can see that they have a wording that is kind of similar, but the meaning of these questions is totally different. The first one, how are you? You want to know how are you feeling? How are you doing today, right? With the second question, how old are you? Basically, we want to know the age of the person, right? So the meaning is totally different. So based on that, we can say that these two questions, they are semantically different. If we analyze the other two questions, how old are you and what is your age, we are going to see that the wording is totally different, but the meaning is basically the same. We want to know the age of the person with these two questions. So based on that, we can say that they are semantically similar. Another important concept is sentiment analysis. In this case, the idea is to analyze the test to determine the tone of the test. It may be positive, negative, or neutral. In this case, for example, for this phrase, I love QA, we can say that it has a positive tone. Generative AI, basically, we use AI models to generate new content. Let me give you an example in the QA field. We can use a generative AI model to generate new test cases for a requirement or for a user story. Discriminative AI, in this case, we are not interested on creating something new using AI, but classifying existing data into different classes or categories. A common example is when we receive an email and this email may be classified as spam or not spam, depending on different characteristics of the email. Finally, we have AI hallucinations. AI hallucinations is when we have an AI model that generates incorrect or misleading results. And it may be caused by different factors. For example, insufficient training data, incorrect assumptions made by the model, or biases in the data. And we're going to see an example about this to clarify this concept. In this case, we have this question: who won the Nobel Prize in Mathematics in 2021? And the AI model generated this answer. The Nobel Prize in Mathematics in 2021 was awarded to John Smith for his contributions to algebraic geometry. If you see this answer, you can think that probably it is a correct answer because it has a professional tone, a formal tone. Also, it is giving some additional information about John Smith that is supporting this fact, right? But in reality, this is an AI hallucination. Why? Because the Nobel Prize doesn't have a category for mathematics. Okay, now Jennifer is going to tell us how we are integrating these AI concepts into our testing framework.
Thank you, and hey everyone. Well, so far we have seen why the conventional automation frameworks are not enough to test this type of non-deterministic applications. And also we have checked some concepts that are very important regarding AI that we applied in our framework. So now we are going to explain you how we integrated both words, AI and automation, to generate a new kind of framework that let us test those non-deterministic applications. First, talking about generative AI, as we just saw, this AI helps us to generate new content. How are we using it in the framework? Well, basically, we are using a question, a normal question, and automatically with AI, this question is rephrased using a specific style. In this or with this approach, what we want is to have a more realistic scenario, trying to test the application as a final user. We have one example here. So for instance, we have this question: what's migration business about? Or unit about? So if we use AI and apply a formal style, we can get something like, could you please elaborate on the purpose of migration business unit? If you see, we have the same meaning in this question, but the wording is different. And also, even we have more questions here. So sending both questions to the chatbot should be able to answer a similar text with the same meaning. The chatbot should be able to understand that it's the same question. Okay, in this example, it was the input of the chatbot, the question. Now we are applying AI to validate the output of the chatbot, which is the answer. Here we have a couple of validations using AI models. The first one is semantic similarity. Here what we do is that we evaluate the expected answer against the real chatbot answer. Since every time it can be different, because the chatbot, again, it used generative AI to answer, so we cannot evaluate the exact test. It's why in these cases where we say that a conventional testing framework doesn't work. In this case, we need to evaluate the meaning of the text. On the other hand, we have the sentiment analysis. Here, what we evaluate is the tone of the answer, evaluating or checking if the answer that the chatbot is returning is in a correct tone, is polite, is professional, and is not using a negative tone. Okay, now we are going to see more details about the framework, starting with the data-driven test. In this case, this is a well-known automation methodology. It's not new, it's not AI. In this case, it's something that is very common in automation frameworks. Basically here, what we are using is separating the test logic, the script, from the data. And the data will guide the test cases that are going to be executed. This methodology can store the data in a CSV file, in a spreadsheet, or even in a database. In our case, we are using a CSV file to do it. And here I have an example of one of them. Here we only have 5 questions. In the first column, we can see that we have the list of questions. Those are the questions that we call original. Then each question should have an expected answer. The next column is the keywords. So here basically what we do is we include a list of words that must be part of the answer. If you see, we don't need to include keywords for all of the questions, but in some cases it's needed. So for instance, if you want to validate the list of members of a specific department, you need to be sure that the list of names are going to be there. So the chatbot can vary the answer with different wording, but the names must be there. So in this case, we included some keywords for the example, and we will see one execution with this validation in the report. And then we have the department. Basically, we use that column to classify the questions in order to see the coverage that we have per department. And also we use it to filter in the report. And finally, we have this tab. Here is where we defined the list of the styles that are going to be applied to the question. Here in the first line, we have original. It means that the original question is going to be sent to the chatbot without any modification, but then it's going to be sent using a formal style and then an informal. It means that for this row, this question represents 3 test cases. 3 questions are going to be sent to the chat. This is something that we can configure. Also, you can add more styles in this list to try to evaluate or simulate a more realistic scenario. Here we have the architecture of the framework. So basically, starting with the CSV file that guides all the test cases that are going to be executed, each question is going to be sent to the AI layer. Here is where the AI model, will take the question, apply the style, and generate a new question with that style. And then it is sent to the communication layer. We need that layer because the chatbot is a totally separate application of our framework. So we need a way to access, to communicate with it. In our case, we are using an API. So basically here we implemented the authentication to that API, and also we call to the specific endpoint to send the question and get back the answer. Once we have the answer, it's sent to the validation layer. Here's where the different validations can be executed. So here we have the keyword validation, the sentiment analysis, and the semantic textual similarity. The last two are the ones that use, again, artificial intelligence to be able to analyze the answer and evaluate it. Finally, when all the test cases are executed, a report is generated. And this is important because with it, the QA team can see the real behavior of the chatbot and identify if there are issues that they need to report. Okay, now Juan Jose is going to show us a demo of the framework. First, we are going to see the script where all the steps are executed. And then we are going to see how to execute them in a CI process and, well, in a continuous integration process. And finally, we will see an example of one report.
Okay, here we can see that structure of the test case that we are using in this project. As Jennifer said, we are following a data-driven approach. So it means that we only have one test case. The different rows of the CSV file are going to use this test case structure to be executed. In this test case, we can highlight a couple of things. The first one is that we are using PyTest as our testing framework. We are also using Allure, that is our reporting tool. That's why you can see some annotations about them in the code. And now let's talk about the test case itself. The first step, of course, is to read the CSV file. Here, you can also see that we are using environment variable to store the name or the location of the CSV file, because that allows us to use different data sets to execute this test case. We're going to see an example of that later. Also, now we have defined some steps as part of our test case. The idea is to have a more human readable test case, and also to encapsulate some information in these steps. Let's talk about the most important steps. The first one is generate a question. We're going to check that more in detail to show you how we are creating a new question based on the style defined on the CSV. Here we can mention a couple of things. The first one is that we are using Bedrock, which is an AI service provided by AWS. And also we are using prompt engineering to give the instructions to the model to generate the new question based on the style defined in the CSV. Okay, the AI model is going to return a new question for us. And then we are going to use this question in our automated test. Once that we have this question, we are going to send this question to the chatbot, and we are going to wait for the chatbot response. And let me show you how chatbot response looks like, because that's important as part of our test case. Here you can see that we have this question, what is gap? And the chatbot response contains two different sections. The first one is the text of the answer. And also we have another section for some additional sources. Basically, we have some links, that we can visit if we want to read additional information related to this answer. So in our test case, we need to split the chatbot answers into different variables: the text of the answer and the sources of the answer, because we are going to perform validations on each of them. With the text of the answer, we are going to validate the sentiment analysis, the similarity of the answer. We are going to compare the expected answer against the chatbot answer. And also we are going to validate the keywords. And with our sources, we have a validation that we're checking if those sources are valid URLs. Okay, and finally, as part of the test case, we are also adding some information dynamically to the report. For instance, we are adding the new question that was generated that is going to be part of the title of the test. So that's why we need to add this information dynamically. Okay, as you can see, this is a very straightforward structure. Now we are going to see how these test cases are executed. And for that, we are using GitLab, which is our CI/CD tool in this project. Here you can see the list of pipelines that have been executed. And let's check the schedules section as well, because this is one of the approaches that we are using to execute our test case. Let's check the first one more in detail. Okay, here you can see that we can define, for example, a specific schedule when we want to execute our test cases. And also something very important about this schedule job is that we can override environment variables. So here you can see that we are all, using again the CSV file, basically because with that we can define different data sets. For example, we can have a data set for a regression test, and we can have another data set for a smoke test. We can also have different data sets for different environments, for example, for production, staging, development, etc. Another variable that we can override is the base URL. So if we want to run our test cases in the staging environment, we're going to use the staging URL. And if we want to run our test cases in a production environment, we're going to use the production URL, right? So with this, we can create different combinations according to our needs. Now, going back to the pipelines, let's check one of these pipelines to see the structure of the pipeline. And here you can see that we have a common pipeline structure. In the first stage, in the build stage, we are building our test environment to be able to execute our test cases. So we have a Docker file where we have listed the different requirements that we need to execute our test. So for example, we are installing PyTest, Python, Allure, and also some AI libraries that we are using as part of our test. We are creating a Docker image that we are going to use in the following stages. Then we have the test stage where we are executing our test. Let's check that job more in detail. Something interesting here is that we are running our test cases in parallel to save some time. So here you can see that we have created 4 different workers. Our test cases are going to be distributed across these 4 workers. Then if we scroll down a little bit, here we can see that test cases that were executed. In this case, we have 228 that pass, and also we have 48 that fail. And it took around 6 minutes to execute these test cases. Okay, if we go back to the pipeline, we can see that we also have a stage to generate our test report. And also in this project, we are taking advantage of a GitLab feature, which is called GitLab Pages, that allow us to store our report in a server to also be able to generate an URL that we can share with different people involved in the project. So here in this job, you can see that we are generating a URL. And if we open that URL, we're going to see finally our test report. Now Jennifer is going to tell us more about this report and also show some scenarios, some validations and so on.
Correct. Well, here is where we can see the summary of the execution. Alor give us an overview of the execution. Here we can see that the total number of test cases is 282, and also the percentage of pass and the number of failures. Also, we can see a trend graph in order to compare the last execution with the previous one and check if there is some behavior that is not normal compared with the history, or if we have a spike of failed test cases, things like that. Also, if we move to a specific example, if you go to the details, here we prepared some specific questions that show us interesting highlights about the validation. First, we are going to filter by one of the departments. And the first scenario that we are going to check is, well, in this case, we are sending the same question with different format or different style. If we go back a little bit to the example, for this question, we executed it in 3 different ways: original, formal, and informal. So let's see the results. The first two, running in original style and informal style using the same question, the test cases passed. But for some reason, running it in a formal style, it failed. So let's check first the past test cases. If you click on each one, well, you can see the information about the question, the style, and the tag that is associated with the department. And also here we can see the different steps that Juan Jose explained us as part of the test script. Clicking on each one, you can get more information about parameters and things like that. But at the end, we can see the output of the execution, which is very important for the QA team. Here we can see, well, this is the question already asked to the chatbot. In our case, or in this case, since it's original, this question is the same that the original question. It didn't change. The expected answer, well, the question is, how can I be part of a center of excellence? The expected answer is, to be part of a center of excellence, you can join the Slack group or contact their leads as suggested in the text. And also, it includes more information about the Center of Excellence. The real chatbot answer in this execution was, okay, to be part of a Center of Excellence, you should first visit the COAS page for more information. Then get in contact with their leads by joining their Slack group or contact them directly. And also it has more information. But if you see, the meaning is very similar, but the wording is not the same, it's different. Even we have something at the beginning that we don't have in the expected answer. Okay, let's see the validations. So, well, in this case, we don't have keywords, so that validation was not executed. But the sentiment analysis defined that it is in a positive tone, it passed. And the similarity score got a 0.6. What does it mean? The score means that if it is 1, this is a value between 1 and 0. If it is 1, both texts are exactly the same. If it is 0, they are completely different. But if it is in the middle of them, there is some similarity. In our case, we are using a threshold of 0.5 to validate the similarity. If the score is higher than 0.5, the test case will pass. Why we selected that number? Well, we did several executions, we analyzed the results, and the 0.5 give us a range where we could allow a differences between both the expected and the chatbot answer, but keeping the meaning of them. So in this case, since the value is higher, the test passed without any problem. Okay, using the same question, but applying, in this case, let me open this, an informal style, we can see that the question changed a little bit. How can I join a center of excellence? Even with that change, the chatbot, well, it says that it's a positive tone, and it found that the score is 0.72. And let's see the answer. Based on the context provided, you can join a center of excellence by getting in contact with their leaders and all the information. So we can see that the chatbot was able to answer again with the correct information, even that we sent a different question with a different style. But now let's see another example using the same question, but formal style. In this case, we can see that the question is longer, has more words or more text. And the question was, what steps should I take to become a member of a center of excellence? If we see the answer, the chatbot said, hey, I did not find the information you requested. Please feel free to ask if you have another question. I am happy to help. In this case, the chatbot couldn't find the answer, couldn't find the information to return. Definitely, this is something that we should report to the team. This is something that the QA team can report. And here the QA team has all the information that they need to report it. They don't need to run the test or they don't need to ask the question again. They have the question sent to the chatbot and also the information with the answer. On the other hand, well, we have here a couple of examples validating the other two things, the other 2 points. In this case, we are using keywords. So for this question, what is gap? We are expecting to have a list of words in the answer. This is the chatbot answer, so let's check if we can find all of them. So we see that technology is there, services is there, even data engineering and modernization. But if we look for machine learning or even for implementation, they are not part of the chatbot answer. So we can see in the assertion error, the 2 words that are not in the answer. And here is where the QA team can analyze it and raise their hand and say, well, is it needed to have this information? If not, they just need to remove it and update the list of keywords. But if yes, they found a bug with the chat. And finally, the last example is about the sentiment analysis. In this case, the question is, what is the dress code? So, well, the correct answer is, well, the dress code at Gap is casual. Employees are expected to wear comfortable and practical clothing, suitable for their work, and it has more information. But the chatbot answer was, the dress code at Gap is casual, while employees are expected to wear comfortable and practical clothing. So far, the information is okay. This doesn't mean they can show up in beachwear, which unfortunately happens. It's sad. So definitely this part is not correct. It's not part of the information that it should return. And also if we see it, it sounds more like an hallucination, right? In this case, using the sentiment analysis, well, it defined that it's a negative tone, and we could find the issue. Right now, we don't have any specific validation for hallucinations, but we can catch them using the other 2 validations that we have, the sentiment analysis and the similarity of the text. Okay, well, so in general, we can see here that the different validation works. Interacting with the chatbot, the framework is able to send questions and validate answers. So going back to the presentation, based on what we have right now, that has given us excellent results. Also, we would like to add another feature to the framework. Taking advantage of artificial intelligence, we can say that we can include a new feature to generate new questions and expected answers automatically. So far, we need that the QA team create a list of questions and expected answers and include them in the CSV file. This is a process that needs some time. But if we use the source of truth that the chatbot uses to return the answers, we also can generate more questions. And in that case, we can increase the evaluation, the coverage of the framework, and also we can reduce the time to test. So in conclusion, or as a summary, of the information that we presented, we can say that, well, we found some challenges in this process, but also we have found some benefits. But with those benefits, or even with the challenges, talking a little bit about the challenges, well, it's important to understand that we are interacting with a dynamic application. So meaning that one specific input may return a different output every time, which is something different to the traditional frameworks. Also, talking about benefits, we can say that we can reduce the time and have more realistic scenarios. At the end, we can say that both, the combination of both automation and AI gave us excellent results, and we can say that this implementation works. So thank you very much.
Hey guys, thank you Jennifer and Juan Jose for the information. Now we can move on to the Q&A section. If you guys would like to, you can leave that in the Q&A part of the Zoom, or you can just raise your hand and I can give you permission to talk if you have any questions that you would like Jennifer and / or Juan Jose to address. Okay, Sandra says great, thank you, and she also says hi, Jennifer. I don't know if you
Hey.
guys. There's also a lot of applauses in the meeting. Okay, I see someone has their raised hand. I'm going to give you Stephanie permission to talk, so you must be able to do so right now.
Hello guys, do you hear me?
Yes, go ahead.
Okay, I have a question. For example, it says in what Jennifer already explained about what is dress code and what is the dress code in GAP. But for me, what is like the definition of dress code? Why not use which is the dress code in GAP, for example?
Okay, but can you elaborate a little bit more the question?
Well, the question is that, for example, I understood, or when I read, what is the dress code? And the second question is, what is the dress code in GAP? For me, what is like the definition of dress code? No, which is the dress code that we can use in GAP, for example, or not? What is the dress code that
So
it's?
in this case, you say that maybe the wording of the question can be improved.
For example, yeah, that's why I'm asking. It's like a suggestion, no?
Sure. And this is something important. Totally true. The idea, and in this this is part of the testing. The idea was initially that we start creating like well-elaborated questions to send to the chatbot, but also we need to validate that even sending short questions with short things, because it doesn't mean that people always are going to elaborate good questions with a lot of content and with a lot of meaning. So definitely, if you send a elaborated question, well created, probably the chatbot will answer better or will find the correct answer. But what happens if you send something short with some important keywords? The idea that the chatbot also is able to answer. In this case, we can say that it is a good test because you don't need to create like long questions with a lot of wording. So that's part of this process. Sending short questions, even we send some questions without a lot of sense or even with typo to see if the chatbot was able to answer.
Okay, got it. Yeah, because I was thinking like, why don't like use which is the dress code allowed in GAP, for example?
Exactly.
That wasn't.
Yeah, exactly. The idea is that one, send good ones and even sending bad ones with typos, but see if the chatbot can answer, can get the meaning of the question.
Okay. Thank you, Jennifer.
No, thank you.
Great. Thank you, Stephanie. We have here in the Q&A section, we have Florian who says no questions, but great talk. Thank you. Okay, thank you so much, Florian. And we also have Sergio with a question. He says, I saw it was implemented using PyTest. Can it be implemented using different frameworks slash languages? What could be another common application besides a chatbot?
Okay, I can help with that question. Yeah, we use Python, especially because probably as you know, Python is a language that is very used in data projects. Because of that, also Python provides several libraries or packages that we can use to work, for example, with different AI models. In this chatbot, for example, we are working with Sentence Transformer, which is a pre-trained model that we use, for example, for the semantic similarity comparison. And in Python, we already have a library that we can use to access this model easily. But of course, we may use other languages, but this aspect, for example, the libraries that we will need in our testing framework is an important point that we will need to consider. And if we have access on these new languages that we would like to try, right? About what could be another common application besides chatbot. This may be related to the this concept of non-deterministic applications, right? Most of the AI applications probably they are going to be non-deterministic applications because the output is going to change every time, right? Because it is going to change because it is generated by an AI model. That's why it is changing every time. So of course, this framework is tailored to this chatbot because that was the goal. But I can see that we can probably replicate this structure, like having this kind of validations using semantic similarity, sentiment analysis, probably for other AI applications as well.
Perfect. So we have other two people that would like to ask a question. First, let's start with William. I'm going to give you permission to talk, so you can go ahead and do so now.
Yeah. Is there a way to, like, for example, like as Gapter, like for example, download the repo and even try to contribute with the source code? I don't know, like, because the best way you can stick with new technologies is using it. I'm thinking if we have an opportunity like that in this kind of project. I have another question as well, but I think it's...
Yes. Well, I think this is a great question. Maybe, well, at this point, it is in the GitLab repo inside Gap. So I think that we can give access. But yeah, definitely, I think this is something that we can be asked to the technology team in order to see if we can have a kind of lab for the rest of the Gapsters to download it and contribute to it. So I think more than a question, it's a suggestion. William, thank you very much. We can follow up it.
Thank you so much.
William, you mentioned that you had another question, right?
Yeah, I don't know if there is a time right now. So the question was related to I saw in the diagram that we have three models. So basically the tests are using the PyTest is using two models to validate the output. Is that right?
Well, basically, we are using AI models in three parts.
Yeah.
One is to generate the questions, and the other two to validate correct. We
Yes.
use
So,
go ahead, sorry.
Go ahead, sorry.
We use AI models to check the sentiment analysis, the tone, and also to check the similarity of the text. So both validations are performed in the answer, correct?
Yeah. So my question is aligned to the problem that we have in AI that you have outlined, like for example, as hallucination, bad answer, and so on. So we have some other option that we can consider. Yeah, just more. I'm thinking more in the in the testing time, where like for example we can use another kind of classification, or I don't know, like looking for main keywords that are more accurate than AI. So was that considered, or it doesn't work for this case? I'm thinking about that. I don't know if I like explain it properly, the point.
Okay, yeah, I think I got your point. Since there are some issues, for instance, the hallucination part, but in this case, the issue, if we think, was caught by the framework. So it means the validation works in that case. The hallucination was more related to the chatbot answer. So since the framework is testing the application, in this case, once the QA team analyze and know that there is a bug in the application, they can report it to the team. And in that moment is where the team needs to see how to fix it in the chatbot. So I
Okay,
don't know if it.
yeah, I was thinking more in, like, for example, you have a classification model, which is AI based. So we have more accurate classification models that are, I think are the way is deterministic, but they are kind of like, they have the I don't have enough context to talk, but yeah, they are, based on what I have seen, they are more accurate than,
Accurate.
yeah, than
Mm-hmm.
AI models. So yeah.
I think I see your point. Yes, in this, well, and this was something that we did at the beginning. We tested several models in order to provide a better result. The ones that we are using right now have been working very well, but it doesn't mean that are the only ones that you can use. And also, so far we are implementing a couple of validations, but also there are more validations that using AI you can include. For instance, talking about hallucinations, what about if you include a validation specifically for that? So that's the cool part of this. Since this is a framework that we are creating, we can add more validations in the validation layer that can help us to improve the final result, or even changing the models that we have, because the models that we have are working fine, but it doesn't mean that we cannot test another ones that can give us better results.
Yeah, and yeah, is a great work, I will say, that you have done. Yeah, you have a pretty good use cases that you have show and present. Yeah, so
Thank
thank
you,
you.
William.
Thank you, William. So finally, I think we can have this as the last question for now. Giancarlo asks, "Hi, I would like to know how does the framework scale as more test cases or questions are added?"
Okay, I can help with that. Yeah, the framework is very scalable. So if we want to add, for example, more questions, more test cases, right, in the end, we just need to go to the CSV file, add a new row in the CSV file, and that is going to be translated or converted into a new automated test, right? That's why we are also using this data-driven approach, because as Jennifer said, we can separate the data from the this case. So we can even have this data set in another place, and where people can go and ask questions without need to commit changes to a repository and those kind of things. And because we can read this CSV file in our testing framework, right?
Perfect. So finally, we also have a final comment by Sonia Sivaja. She says, great presentation, Jen and JJ. Definitely very interesting and useful. Thank you. So
Thank you,
again,
Sonia.
I would like to also thank you guys for your time. And of course, thank Jennifer and Juan Jose for all the knowledge and all the very insightful and interesting topics that they covered during this talk. And also thank you for all of you that joined us during this webinar. We invite you to stay tuned to our social media. We appear as Growth Acceleration Partners in LinkedIn if you'd like to stay in touch. And also stay tuned in our channels and everything for future talks that will continue to contribute to our knowledge and professional development. So without further ado, thank you and have a good afternoon. And also, finally, Anna says great talk and thanks for sharing. So I think that will be it. Thank you again, Juan Jose and Jennifer, and thank you all for attending.
Thank you, Camilo. Bye.